Hello, this is Lindsay Boggs, and this is Project 3 SneakyMcSneakFace for GPE 104. I did not make up the name of the project. It is actually called SneakyMcSneakFace. But I've renamed it something different. Spyro, A Life of Crime, because I thought that sounded much better. But anyway, tomato, tomato. Requirements for this project focused on the Canvas UI system, and then finite state machines, different AI senses, and controller and pawn logic. Within that, there were other requirements in a separate sheet, using Canvas screen space, world space, scaling, text objects, image objects, buttons, game managers, and FSM for game state, AI finite state machine, hearing capabilities, vector 3 distance, AI vision, vector 3 angle, physics 2D raycasts, controller parent classes, AI player controller, which also inherit from a controller class. Okay, yeah, they're a controller class, parent pawn class, etc., 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 plus extras. That does not need to be highlighted. Anyway, there's a lot of cool stuff to go over. I was really excited about this project. This one's probably my favorite in the class so far. Just because the more I learn, the more I want to do. I get myself in danger sometimes because then I overscope what I would like to do. But this is pretty cool, so I'd like to just jump in. First of all, where to start? Let's go in order. Okay, Canvas UI system with text, buttons, and images. All kinds of good stuff. This obviously is a title screen. And if we open it up, you'll see that this is a canvas, and we have this background image, which is the snowy area. We have a title image, which is the Spyro Life of Crime. This I took from Sprite's resource. It was Spyro Attack of the Rhinox, and I photoshopped it and made it a different thing because SneakyMcSneakFace, this is Spyro Life of Crime. The premise of like this game that I was intending to make ended up being a little different than what actually came to be to demonstrate all the needs of the project. The premise of Spyro Life of Crime was that he infiltrates Moneybags' area and steals back all of the gems that Moneybags swindled from him. However, I should just show you. Might as well. I do actually have like art and everything set up for Moneybags. Moneybags did not make it into the final project. He's not in sprites, he is in prefabs. Pardon me. Yeah, and he's fully animated. Look, well, he walks around and stuff. But because of his perspective, for example, if you saw just this sprite rotating around on a plane, it would look bizarre. You wouldn't be able to use like the vector 3, etc., etc., the way that we've been using it in class. Transform.right and that sort of thing. He would do better with a collider vision and hearing because when he turns, he has like a completely different animation. His eyes end up in different spaces. Well, in different locations than the top-down thing would be, like this. Okay, so you can clearly see what I'm talking about. This sprite, you can just rotate, and it shoots a straight raycast, whatever way it's turning. Anyway, the cat is named Diamond because this is my workaround, was that rather than protect his gems himself, he has his pet cat, Diamond, protecting them, and she will come after you. And of course her name is Diamond because what else would Moneybags name his cat? So I thought that was kind of fun, and that's the story behind the game. Anyway, back to the buttons and everything else. There is just a standard button. However, this text on top of the button is not your standard UI text. So I did not go UI text. I went to Text Mesh Pro text, because in one of our online discussions for the class, we were tasked to research other options. So we were taught the text, basic text, and the basic image. What I chose to research specifically was this Text Mesh Pro, and what I learned was that the text is going to become a legacy feature, and this Text Mesh Pro is going to become a standard because it renders better, you get sharper, crisper edges, and it's actually less processing on the engine. It uses less polygons, and it's pretty cool. So I used this throughout the entirety of my project because it's going to be the thing to use, and this is going to go away. So that's why that's set up the way that it is, and I left this Text Mesh Pro text suffix on the end of it just to like reference that throughout. So that's just the start screen. Now let us go to the, ignore that, gameplay screen, and we actually need to enable some things here because there's a lot of other stuff going on. Level objects, there we are. On the gameplay screen we have a variety of things. First of all, we have things that are unrelated to the screen. Let's just address that right now. These level objects exist separately from the canvas, but they're enabled at the same time, and I can show you where that is in code if you'd like to see it. There's different things, of course. There's grass, the walls. I have waypoints set up for the cat, and so she can patrol around, and then of course gems, and Diamond the cat, as I'd said, is her own thing, and she has a canvas as well to show world space canvases. So level objects in conjunction with the gameplay screen are what makes up the gameplay. Now this screen is a canvas overlay. We have this Lives Sprite. Once again, we have a Text Mesh Pro object, which is over here. If I can shrink that down, you can see just some of the different components that go into this. And then there is a timer sprite, which I created myself. So I thought that was pretty cool. There's an underlay, and let's go top to bottom here. So if I disable some stuff, perhaps, yes, okay. These two things are gonna look the same, but I changed the color in code. So to start off with, there's an underlay. Just looks better that way to kind of provide some depth between that and the rest of the world. And then there's this blank image, because that is exactly what the timer looks like, as you can see down here, a little preview of it. It's white as its base color because we're going to change it in code. And on top of that, oh, okay, one more thing. So the overlay is my goodness gracious, simple fill, okay? So it's not going to go anywhere, it just stays exactly how it is. The blank is a radial 360 starting from the top. So it's going to count down like you would expect a timer to count down. And then the actual sprite is also radial. So as the time goes by, when it gets to the first eighth, so it's divided into 1, 2, 3, 4, 5, 6, 7, 8 pieces, it gradually changes color through code. So that's why these different color pickers are here, because they're all public. I will wait to show you that, show it to you all at once. Gems. This sprite here, it's a little difficult to see with this angle of the game. Wow, Minnesota accent just happens. Game. Anyway, you'll see that as we walk around a better view during actual gameplay. And then again, Text Mesh Pro text to display how many of these you've collected. This just says 0 as a placeholder, but it's actually going to say like 15 of 15. That updates in code. And then we have some audio components that I've attached to these gameplay screens because this game or project does not change scenes. It's all based on enabling and disabling these different canvases. Therefore, when something is enabled, you can take advantage of the awake feature. So each of these screens has its own music and audio components. This one has two, because when you collect the gem, of course, we have to play the sound. Okay, let's put that away for now. Actually, let's make sure everything's set the way it's supposed to be set. Yes, it is. Okay, and then level objects as well. The victory screen is, of course, just a background image, and then we have the play again option or quit. Quit doesn't do anything in the editor, but in the build, which we have one right here, it will quit the application or restart it from scratch. And then the game over screen is very similar. Again, we have a background image, some text, and then we have try again versus play again, and then another quit button. So, let's play in the editor, and I will show you the, yes, you'll see these things as we play, but I want to focus on the canvas to start out with. So, the menu screen you've seen, goodness gracious. Gameplay, okay, that's enough of that. Screen space and world space, and then scaling is what we're going to focus on. And you've seen these buttons. So let's go ahead and get started with that. Right. So we have our music, which is pretty cool, and all of our screen layover, whatever it's called, screen overlay elements scale with the screen. So no matter what we do, they're gonna stay pretty much where they're supposed to be. We can change our resolution, and we have this nice dark blue background. And these are pinned to the center of the screen, I do believe. Well, the background image is actually enveloped over it, which is why that blue part shows doesn't quite stretch over it. And then the title image, yeah, that is to the center in the middle, as well as the start buttons. So it all stays relative to itself, or to each other, I should say. And then, as we hit the start button, we can hover over it, changes color. We click on it, changes color as well. We start our game. As I'd said, that text updates. Uh-oh, what did I do? I disabled my timer. Okay, sorry about that. Try this again. Okay, our wonderful start screen, and then our game. There we go. Here's my color changing timer, and this is why the background one, the Sprite blank, is in there. Because this gradually updates in code to match the time remaining. So it's based on percentages. So if I just cheated and bumped that up, you'll see that this is dynamic. So when we have 35 seconds, it's going to go about that slow, if I don't get killed by the cat. If I had a max time of 10 seconds, and I had 10 seconds left, oops, there we go, you'll see it really shrink down. Oh. Right. Well, we have a failed screen, as you can see, with some really cool music. Quit doesn't do anything in the editor, and then try again loads us back in to start. Let's go over the rest of our stuff here and put our max time back to 35 before we die. Okay, there we go. The gem audio is a little slow, but that's what you get for free audio, so what are you gonna do? Let's see, we have collision on our walls, of course on Spyro himself. Our heads up display is updating. You get a better view of that gem. Cheat. Give myself extra time here. The UI there. And this cat. Okay. When we bump into the cat, we'll lose a life, and then we get set back to our start point, and so does she. Let us bump up. You can see how dynamic this UI is. I call it dynamic, it's all just code. Lost my train of thought. Okay, let's talk about her states. So right now she's in her patrol state, and if I really give myself some extra time here and some extra lives, we can, there, now we're not going anywhere. Talk about her for a second. So, where are you? Spyro, level objects, main camera, gameplay. Where did she go? I'm feeling just a bit blind, because I do not see her in my... Okay. Oh, she's in the level objects. Okay, that explains it. Sorry about that. Okay. Back to where we were. Diamond is her name, and here she is. So she right now is in her patrol state. As you can see, her current state is in patrol, and there are different waypoints set up around the world that she is traveling to. Unfortunately, I had a little bit of trouble with the collision versus trigger components in code, and then I ran out of time. So she's actually bumping into them. They're collision objects? No. And that's why she looks like she's bouncing off the walls, is because she literally is. She's like running up and tagging it and then running away. It was really funny before I got the eyesight set in, because she looked like she was blind, and I felt kind of mean, but it was pretty funny. So that's what she's up to right now. When she hears us, right now we are making no noise, so if we were to click on ourselves, we have this noise maker. Right now we're at 0, and we have a volume decay of 2 units, if you will, per frame draw. So when we walk, it's going to be a volume of 4, and then if we were to hold the shift key and run around, then we have a volume of 7, and then it decays at a rate of 0.2 per frame. When she hears us, she will enter her investigative state. So if we click on her once again, we can look at her state down here. Current state is patrol. Where'd she go? Okay, so she's still patrolling. She's going around her different waypoints. If she can hear us, let's see. You'll see that question mark pop up over her head for just a second before she sees us. And she can hear us through the wall. She can't see us right now. When she sees us, she'll send out a raycast, and if she can see our collider, then that strikes true. And then she'll come running after us. But her investigative investigative state is slower than her chase state, and she just kind of slowly creeps up towards you. But if she sees you, she will really pick up the pace. I believe her investigation state is 75% of her walk speed. And then her... Oh no, she's stuck. Okay. Her chase speed is higher than that, of course. So, that's how she operates. What else shall I show you? You can see that there's some placeholders things. I had a lot more planned for this project than I ended up putting into the final version of it, but that's fine because this is something that I really enjoy and I like to go back and add it. Working on the premise that she belongs to Moneybags as his pet, I thought it would be kind of cool if Spyro also had a pet cat named Flames, and if you could play as him, that could also show controller inheritance and how controllers work with pawns and that sort of a thing. I have enough to demonstrate all of that in this version of the game, but there is some stuff for me to work with should I choose to do so. Let's see. Let's go ahead and check back with our requirements. Finite state machines. Yes, you've seen the start screen. AI units, AI senses, and controller and prop logic. Okay, let's get a look at this. Let's talk about the game manager state machine first, and then we will go into our AI state machines. So, we have a lot of code in this assignment, so I'm going to try and just give a brief overview of everything as best I can. So there are 4 main states to the game: title, gameplay, victory, and game over. We switch between those based on an enum, which is... that is the enum. And then there's a switch block down there. So there's different things that we're going to do when we set these states within this switch block. So it's within this function here in the game manager, activate screens, and then we're going to switch based on the integer value of this game state from our enum. If we're in the title state, that's the only thing that's active, everything else is set to false. And then this is what I talked about before, this special case with these level objects. I did this because things were acting a bit unexpectedly, so this just gave me more control over where things were placed in the world. Anyway, we set the screens to false, we set our level objects to false, and we have our title screen. If we were to change the state to the gameplay state, then gameplay gets set to active, everything else is set to false, and then we get to activate our level objects. And then also we're going to reset some variables when the gameplay state is enabled, and this is what allows us to go to repeat our game. So we're gonna set the time remaining to max time each time we enable this screen. Therefore we can't start from 0 or anything like that, and then of course our gems collected also need to start at 0 because we're just enabling gameplay. We're not going to start with several gems collected or anything like that. And then when we need to load our victory screen, everything else gets set to false, this gets set to true, turn off the game objects, and then it's the same thing for the game over screen, except it's the game over screen and not the victory screen. And then game objects also get set to false. So that's pretty much just how our state machine works. It's pretty simple. It's just a switch case and an enum, just turning things on and off, but it's pretty fun. Then we also have this function here, which allows us to set the game state based on this piece here that we put in, and then we call that function to activate screens. And then we also have a quit game function for our quit buttons, which allow us to quit the application in a build, not of course in the editor. So that's it for the game manager. Now we get to talk about the AI finite state machine. This was an interesting experience. I think I learned the most from this assignment, and by that, I learned the most from this assignment. Okay, so let us open up the controller and the, here we are, AI controller, and then diamond pawn is what we're going to be looking at for this. So the controller, how do I want to explain this? The pawn describes how, diamond pawn describes how the pawn is able to move. The AI controller describes when these things should move. So the controller is like our finite state machine here. As you can see, we have a enum, just like we did in the game manager. She only has her 3 states, as I said: patrol, investigate, and chase. And the controller tells us when these things should occur. The pawn tells us how. So controller is when, pawn is how. Pawn also inherits from the pawn, I would say master class, parent class. And this is pretty simple and pretty empty, but it allows for a lot of flexibility with other classes, I suppose. We also have a player controller, a Spyro pawn over here that inherits from this class. So I've divided things up to keep things organized. Tank control patterns, which would have been used for flames had I entered that as like a second pawn option. Cardinal movement directions are for Spyro, and then enemy functions are for diamond, and then we have some overlapping pieces of that Venn diagram that everybody gets a slice of. So, let's go through the pawn. So this is how she's going to move, based on a lot of different things here. We have target object destination, an array of waypoints, that's for her patrol, an index, which is public because we need to be able to reset that within a gameplay script to 0 on enabled. And then we have her little space, world space canvas above her head that shows the question mark or the exclamation point for her. Rotate speed, walk speed, etc., etc. Okay, we'll get into that when we get into this stuff. So on start, we're going to override the start function that we inherited from the pawn parent class, but not before we call its base script. So with its base script, we get a TF and a start position. And we also inherit this function down here from our class. It's the teleport start, which will come up a little bit later. Anyway, this is just the start function. The teleport is just inherited by default. That's what inheritance is. But anyway, my position is going to be set to this tf.position just for some simplicity's sake. We take our index and set it to 0 on start, so she's going to be going for the first index in her array. And then we take this destination, which is a vector 3, and we set our destination to this waypoints set to this index, which we just set to 0, and we take that position from that index. So the waypoint object within this array, we grab its transform, and from the transform we grab the position, and that is where we're going to be sending our cat. We don't have anything for her for update because all of her update things get set in the controller, because the controller dictates what she should do and when. The pawn is just a template for how she moves. So when she's in her investigative state, or while she's hearing the player but not seeing them, she's going to be moving around a lot like our ship from Project 2 for the asteroid shooter. So she's going to be updating her position, her rotation, and kind of gravitating towards the player, but only at 75% of her walk speed, which is coded in there. And then she's going to be setting her reaction canvas to this question mark, which pops up above her head. This caught is only specific to this pawn. It was a special instance. It does not get called in the finite state machine. And that's if the player collides with her, then both players Actually, well, if she's a controller, she could be called anyway. Both characters get teleported back to their base start, which, as you saw, they inherited from pawn. And her reaction text gets sent back to blank. Don't worry about that. Anyway, her pawn function also has a chase, which of course occurs when she sees the player and goes after them for stealing all of the gems. And it is pretty much the same thing as the investigate state, other than her speed is much more precise and direct. And then, of course, this reaction text gets set to an exclamation point. And then while she's patrolling, her destination is no longer going to be the player, where it was before, where we grabbed it off of this chain of events from the pawn of the player controller. Instead, it is simply going to be the next game object within our array of waypoints, grabbing that transform in position. And then we also have another piece to her patrol that's going to be coming up in just a second. And then while she's patrolling, we're not going to be having her expressing anything. So, on collision with this pawn, we're going to be looking for waypoints. So this is what I was talking about here with this patrol. There's more to it than that. When I had set her... Okay, so back up just a frame or two. Originally, I had her setting her destination to the transform position of each waypoint, and then when her position was equivalent to the waypoint position, I would have her increment her index and then reset the destination to that index. But she was literally getting hung up with that, and I'm not sure why. But I found a workaround, and it came with its own set of problems, but that's okay. It worked out in the end, so that's the good news. Bad news is she runs into the wall, but that's okay. It's okay. She'll survive it. So when she literally collides with these waypoints, we're going to increment the index, and then we're going to check to make sure that it isn't out of scope, or out of range, so that it is no larger than the length. I was still getting an error. There are 18 indices. There are 19 waypoints, because we have 0 to 18. So, the 18th index is the 19th waypoint. So, when the 18th is the last index, and then we increment it to 19, we need to catch that here and set it back to 0, so that we stay within our scope, or our range, But, this fixed the error. Honestly, this should have been enough to do it, but whatever gets the job done. And then we're going to set our destination, which once again is a vector 3, to the position of that index, whatever resulted from this incrementation right here. Okay, so that's what happens when she collides with a waypoint, and then when she collides with a player, that's when we call this caught function that's just specific to this pawn. sending them both back to their original start locations. And then when we do send her back to her start location, we want to reset her on her path along her waypoints so that she doesn't get crossways. And then we're going to decrease our lives by 1 when we get caught by the cat. Okay. AI controller. So that's how she moves. And now we're going to determine when and why. With our AI controller, we have some senses in here. So hearing and sight. Our transform, of course. And then here's our finite state machine. And that, as I'd said, has an enum with patrol, investigate, and chase. And then we have our current state. And we have a float for stop chasing distance. We override our start function, but first we do call our base, which gets us our TF. Oh, excuse me, no, this is the controller. Controller parent class right here. Okay, controller parent. It's an abstract, by the way, as well as a pawn. They're both abstract classes, so that we can't create an object of these. We can only create their children. They're kind of like ghosts in a way. I don't know. They just, whatever. We call up this controller parent class, and from that we get this variable for pawn, and then we're also going to set it on start. So we're going to get the component of whatever's on this object. Go back over to our AI controller. After we run that, we're going to grab our other needed variables. So the AI hearing component, sight component, and then of course a transform are going to be grabbed from components that are on the object. And then we're going to start calling our updates and making some decisions about what this cat should be doing. The current state is going to start off in patrol. And so when she's in patrol, we're going to check for a couple of things. If she hears the player, then she's going to start to investigate. The question mark will pop up and everything like we'd seen in these functions here. So we just call that function, we call it a call function. We set the state, and then that goes into a chain of events that eventually calls the function. And then we're also going to be checking if she can see the player, or the pawn, rather. And if she can, then she will chase them. Okay, so let's see. If we were to hear the player and not see them, we'd go to investigate, in which case we would switch on the next frame, since this is an update. And now we are investigating. While we're investigating, we're going to be checking some other things. If, in the course of our investigations, we see the player, chase them. If they leave our range, so there's this distance here that gets kind of verified with a couple of other things, then we will resume our patrol. Otherwise, if she can't hear us any longer, she'll also resume her patrol. And then if she were to begin chasing us, which happens when we cross her line of sight, then of course we'll enter our chase state on the next frame. And then if she can't see us anymore, she's going to start investigating, because we've just broken her line of sight, but she's just coming from chasing. So she knows we're around here somewhere, but she's going to be a little bit more cautious. And then if we leave her range, then she's just going to resume patrol. So that is the controller. The first child of that controller. We still have to talk about player controllers. And then we also have a pawn controller that we discussed briefly. And the first child of that. She was actually the second child, but don't tell her. Anyway, the second child of that object class. Not object class, abstract class. So, hearing. All right. Hearing and sight. So these take in a noisemaker. So there is a noisemaker on the player, which I don't seem to have open. Let me just grab that really quick. Do believe. Yes. Okay. So the noisemaker is a component that goes on the player, and it's just volume and a volume decay. So we will have the volume set by a designer or in the editor. And, or excuse me, the volume is not set by the designer in the editor. The volume is set in code when we are walking or running or not moving. Okay, so that's why that's public. And then once that's set, it decays at a rate of 0.2, and 0.2 is set in the editor. While the volume exists as it's greater than 0, we will subtract the volume decay every frame, since this is an update. And then I was getting a bit of an error where it was falling down to like negative 6.213 something. So I plopped this in there and it fixed it. So if the volume is less than 0, if it's somehow become negative, just set it back to 0. So it's a bit of a failsafe. So that's why that's in there. Anyway, back to our hearing. I'm going to go ahead and close that just to try and declutter a couple of things. Where did her pawn go? Anyway. Hearing. So we have a noisemaker, and then we're going to be able to interpret that in code. We have a hearing threshold. We didn't end up needing this distance decay. That was not necessary. And then we get a transform for ourselves. So this is on the AI, and we're going to be calling this Boolean can hear, and then the target is, of course, our player pawn. So we're going to grab the noisemaker from the player pawn, and then if they don't have one, then we're going to return false. And if they do have one, which they do, then we're going to check out a couple of things. We need to get the transform of the pawn, since we can hear, well, we may or may not be able to hear them, but we're going to check on that. So we grab their transform, and then we're going to calculate the distance. And if their distance falls within a range that is less than or equal to this noisemaker as it is multiplied by a hearing threshold, then we will return true. So this hearing threshold, like a number 1, is about normal hearing, because at that point it's just the noisemaker.volume. If they had half that amount, so like 0.5, then it's whatever the volume is times 0.5, and it decays at a rate of 0.2 per frame. So that would be pretty deaf. I think I bumped the cat up to, I'll check when we get back in the editor. It was actually, I'm going to check right now. AI hearing. She's at 2. But that I thought was a little bit generous towards the player. We could have bumped that up just a bit more. Anyway, that's our hearing threshold and how that works, and then we'll return true saying yes, we can hear you, and then otherwise it was too quiet to hear, and we're going to return false. So I'll go ahead and save that. Okay, and close it. Now we'll talk about the AI site. So we have a field of view, target position. Actually, the field of view was, yeah, we'll get into that. Okay, lots and lots of variables. Let's just start with the code, and then we'll kind of pull those in as we go. So on start, we're going to get our component, our transform component, so we can use positions and everything. And then when we call this Boolean can see, the target object is, of course, our player pawn. We're going to grab our player's position. So that's this target dot get component transform position. And then we are going to go ahead and set that to my, we need to grab my position as well. So we have the player's position and we have my position, because right now I am an enemy, I'm an AI. And then we're going to calculate the vector between those 2 points. So between the target position, which is the player, and my position, and I am the AI, we're going to get this vector 3, which is up here. And that's our line to target, and then we're going to normalize it, and then we need to figure out an angle. So if our angle to our target well, hang on, I'm getting ahead of myself here. We're going to take our transform.right. Now this is where we get into why I chose to do a cat as opposed to Moneybags, who like literally spins in a 3-dimensional circle. So if we were to open up they are prefabs. Like if he were to move up or north, you would see the back of his head the same way that Spyro moves. And that just was a difficult thing to do for AI. It was fine for the player. But what you need is this transform.right, and that works with the x-axis. So if I were to grab, let's see, that's our game view. Flames, for example, super tiny. This transform.right is this red arrow here. So based on that local space, we're going to be calculating some angles. So that is why, just to reiterate, we ended up using a cat in a Spyro game as opposed to Moneybags, but it was contextualized and that made it okay. So anyway, back to the story. We're going to be calculating the angle from that. So we have this vector3.angle that's made from the line that we just made, our line to our target between us and them, and our transform.right, which is right in the middle of their face. And if that angle is less than our field of view, we're going to go ahead and conduct a raycast, because that means that they're within our view cone, if you will. Otherwise, there's no sense in sending out a raycast. And so we send out this raycast, and we send it from my position along that line to our target. And if we successfully hit them, so if the if the hit info that we get back is going to be a collider, and if the game object of that collider is our target game object that we passed in the beginning, we will return true and say, yes, indeed, that is the target that we are looking for. Otherwise, we're going to return false, and that kind of falls down a whole lot of if statements. So returning false is something that can happen if it is not our target. Okay, next object on the list, vector3.distance. We did see that a bit as I just closed out my site. We saw that in the AI controls. So actually, is that still open? Was it the AI? Vector3.distance. Just think of what script that's in. I can search it. Vector3. Oh, here we go. Vector3.distance. So yes, that was calculating the distance between us and between the player and the AI to transition. So that's just a requirement for my sheet here. So just to show where that is, it's calculating out how that compares to our stop chase distance, and then it was also comparing I'm just going to open up the script before I misquote myself. Hearing. Within our hearing threshold for comparison. So vector3.distance, for the purposes of this project, is used in the same way each time, and that's getting the distance between our position and the AI position, no matter what script it's used in. Alright, there's that. AI vision. We just discussed that, about the transform.right and the x-axis and local space and all of that, and the raycasting. So that's done as well. Vector3.angle we discussed with field of view, and how that was calculated with our visual cones getting an angle between the line that we drew between us and the player and our our transform dot right. In local space, we talked about our raycast. Just a little bit more on raycasting, to summarize it. It's kind of like firing off a gun, or literally like a laser, and then it returns back to you whatever the first object is that it hits. And then another important thing about raycasts are that you should start outside of your colliders or ignore the collider that it begins in. It's up to you. There's a project settings tick box that can adjust that. You can also make it see through triggers in the same area. Project settings, edit, physics 2D. It's that location. Controller parent class we looked at. But we didn't get to look at the player controller yet. So we did do the AI, so we won't have to go over that again. But let's go over the controller parent class. And we did go over the pawn stuff. So, controller. Very simple stuff. We simply have a public pawn, which, again, is our parent class, so that can possess any of our pawns, whether it's Spyro or Diamond or Flames or Moneybags or whoever it happens to be. They all qualify as pawns. So this is very like vague programming. Anyway, we will hold a pawn, and then the child of this class will kind of further differentiate on this code, and we're just going to be getting that from the component that's on our object. There, parent class for controller. Okay, player controller. We run that and then we override it. We don't do anything else special to it. So it's just grabbing the pawn. Now we get to do our own stuff with updating. So now, this is similar to the AI controller and the AI pawn. The pawn dictates how things move. So this is the Spyro pawn, and then since he is our player, this is the comparisons we're going to be making. Spyro pawn says how it moves, and the controller says when. And in the case of AI, it also says why. So let's talk about the controller first in this case, and then we'll get into how he moves, because he was a bit more complex. He has cardinal movement, and we're going to be using those directions just kind of make things easier. So if our up button is pressed and nothing else is pressed, we're going to call the move north function on the pawn. So he inherits from the pawn parent class, which allocates for, or whatever you want to call it, prepares for him. Cardinal directions are right up at the top. So they are blank, and he simply overrides all of them in his own inherited version. So that's, the pawn version is blank. And then we have Spyro here, and movement operations, public override, void, move north, move south, move east. So he's overriding what he inherited from the parent class. And then within the player controller, we're able to call him simply because he is a pawn, because that was how he was brought into this brought into this world. No, brought into this code as a child object, and because he overrides it himself as an inheritor, we get to use his unique thing, which is pretty cool. So, anywho, that's how all of that fun stuff works. Pawn move north. If we are pressing the up and the right key and nothing else, then we'll be moving northeast. If we decide to press the right key, these are mapped to both left-handed and right-handed controls, by the way, so you could use WASD or up, down, left, and right, as well as both shift buttons. This is very functional stuff here. Anyway, hold the right key down, nothing else, you move east, calls that function. Southeast is right and down with nothing else pressed. South is down with nothing else pressed. Southwest is left and down. You get the idea. West is left, and northwest is left and up. Okay, as you can see, this code is prepared for further development with Flames, the cat, because this is a player controller. So he would inherit the rotation movement patterns. So forward, back, left, and right, similar to the ship of the second project that we did in this class. But for the sake of this project, this is, once again, enough to demonstrate requirements. I lost my train of thought. Okay, yes, speed, walk speed, everything else. That's within the pawn. Okay, so player controller says when and why. So the when and why of a player controller is that the player is controlling it, they're pressing it. So this handles all of our input and says when the player is doing this, then we should do that. Why? Because they said so. Okay, but what should we do other than just pawn dot move northeast? What does that mean? Well, the Spyro pawn will tell you, because that was what was brought into this player controller. So we have things like walk speed, run speed. If he's flipped, because I worked smarter, not harder this time, and learned some more about animations, and not only just animations, but flipping the sprite as opposed to flipping the object as opposed to just flipping the sprite, which allows colliders and things to also be flipped and to be accurately mapped to that object, which is pretty cool. So for example, if he had like a trigger box in front of him that he would have to have in order to speak to a character, he couldn't like turn his back to a character and attempt to speak. He would have to be facing them. But if we use this as flipped, that makes sure that that's always in the correct position. So I was kind of proud of that. That was fun to learn. Anyway, and then we also have my noise, which should be like my noise level, be more descriptive. Either way, gets the job done. Like projects in the past, we have an animator, and then this mirror vector is how we do the flipping back and forth for the object. So on start, we override our base pawn start, and then we also get this make noise from our component on the object as well as our animator. And then our update is going to be called. So we have just a base update, and then we also have this mirror vector, which will flip us in the X direction of the local scale. And then the Y and the Z will remain the same. And the reason that this updates on every frame is because we're constantly moving, and what we're doing is we're setting it, we want to make sure that these two things are accurate. Constantly, we don't want to be jumping around the map or anything like that. So, we also have a speed and a volume setter within our update function. And what that does is it allows us to be accurate with our movements. So, if we are running with the shift key, so 1 second. If run is held with some other movement, so this run is both left and right shift, or either one I should say, positive and alternate positive. So if this is held and any of these, so we have this is a requirement, and any one of these, because they're in an OR thing, and they're all encompassed by parentheses. Then our speed is going to get set to run speed, which is open to designers to set. And then noise is going to be 7. And then if any of these buttons are being held, but the shift key is not, or the run key is not being held, then we're not running, we're walking. And we're going to set our speed to the walk speed, and then we're going to have our volume be 4. So the reason why this is important to happen every frame is because this occurs before any of our movement operations get calculated. So if you notice, we're using the same variable speed right up here at the top. And then speed equals 0 only if no input is being pressed. And if no input is being pressed, he's not moving, so our speed is 0. But we don't need to set our noise, and we don't want to set our noise actually, because if we were moving previously and then we stop moving, our volume has that volume decay, so we don't need to set it. It's going to just slowly, rapidly decay over the next few frames and dissipate. But if we set it to 0, that defeats that purpose entirely, and our cat would never be able to hear us. So simply our speed is 0 while we're not moving, just for accuracy's sake. Okay, and then we have our run speed that gets saved into the variable speed while the run is pressed, or our walk speed, which gets saved into that same variable, so that when we calculate this vector 3 up times speed, or vector 3 down times speed, we don't need to rewrite our code. We just get to use whichever variable is stored on that update frame, which is pretty cool. Especially since I added this in after I added the ability to run, after I'd already coded all of this, and I was dreading it, and then, oops, my goodness gracious, I just drug that somewhere it wasn't supposed to be. I figured that out, and I thought that was quite cool. So I wanted to be sure and really emphasize that. Movement operations, very similar to projects that I've done before. So we have this vector 3 dot up, dot down, dot right, and then we get into our is flipped scenarios, because his animations are naturally, up is of course up, down is down, but are moving to the east, the northeast, and the southeast are his base animations, and then to move on the other 3 directions to the west, we need to flip him. And so we do that through the animator, which I will not get into because, well, maybe I will. We'll see here. Anyway, north, south, east, and then we get into, sorry, thinking how do I want to explain this. If he is flipped, then we're going to go ahead and use this mirror vector, so flip him back, and then we're going to update our boolean is flipped to false, because he's in his natural state again. We're going eastward. If we're going west and we have not flipped him yet, then we'll simply mirror him over, and then we'll update our boolean to true. And that's what happens with all of the west variables, and then east is just the opposite. If he is flipped, then flip him back and set it to false. So that's probably the simplest way to explain it without going through everything. And that's the end of his pawn script. Now, pawn parent class we talked about. Bug and error free. This is true with one exception. There is this interesting thing here. It doesn't cause any issues with gameplay. In this asset scripts gameplay line 58. I actually need to talk about the script anyway. But it's the AI pawn, and everything works just fine. So I'm not sure what its issue is, other than she's not enabled on start, which is probably why this is causing an issue. But because gameplay, which exists on our gameplay screen, is enabled at the same time that diamond as a level object is enabled, there is no issue there. So that's not really an error, but it's coming up as one. But it's not yielding any errors in the finished product. And then this other stuff, editor graphs, Unity editor graphs. I'm not sure where this is or what it's doing, but there's nothing visibly wrong with it. So I would say that this is error free. Everything can clear. It doesn't affect gameplay or prevent me from playing. So that's that note. Exceeding minimum requirements, the title image that I edited, which was fun. Gems are collectible. It's the objective of the game. It's part of how we transition to the victory. It is how we transition to the victory screen. And then the animation I did as well. It's a little bit wonky, but that's okay. The timer, I created the image and I also coded how it works. Character animations for Spyro and Diamond. Waypoint patrol for her. And then the music, and ignore that, that was just extra things. Her FSM is done, and that was not extra. Walls with colliders, technically an extra piece, but I would just say that's a necessary thing to have a game, and actually it's necessary to demonstrate the site and how it needs to not be obstructed. Money bags. Okay, I had this whole like story script planned. It would have been really cool. I'd like to do this and maybe put it in my portfolio at some point because this was fun. Controllers and pawns we did, audio we did, and that is set in gameplay. And this, you failed. You heard that jingle, and we will go into that again because we're going to do the build. Alright, so these are my exceeds minimum requirements pieces. Go ahead and save. And let's talk about the gameplay script. So, oh, we're already on it. Perfect. Gameplay script is attached to the gameplay screen, our canvas, as I had said. So it doesn't get enabled until the canvas is enabled through our FSM in our game manager when we click the start button. So this has an on click, and then it's actually hooked up in the editor. It's pretty cool. Anyway, once we reach the gameplay screen, this gets enabled, and there is a lot of stuff that it does on start, and then also on not just start but on enable, because we can continue to loop through this. Should we fail or succeed and want to play again, then we call our on enable function. And then also on the screen, as I'd said, was the audio, which gets played on awake, and that's why it's unique to the screen, which is pretty awesome. So, that said, gameplay script on the gameplay screen. We need to have a couple different variables for our GUI, our HUD, and then we're going to be collecting some strings to display to that HUD, and then our player controller and AI controller, so that we can set them back to the center of the world should we re-enable our game or start the second game within that play session. Second plus. Second and onward. Anyway, start function. So the first time we fire this up, we're going to set our time remaining to our max time, which is found in the game manager, and then we're also going to set our player lives to the starting lives that we come up with. The reason I use start rather than max here is because I worked on the premise that maybe they would be able to earn more lives and therefore get more than the maximum capacity because they're lives. But with how small this game is, that's probably overscoping just a bit. But that's why I named it that way, so just so you know the thought process behind my reasoning there. On enable, when we disable and then re-enable this canvas, we are going to do pretty much the exact same thing. Just make sure that our time remaining is set to max time. If we've collected gems before, we need to set that to 0, because it would no longer have been zero within our game manager if we had disabled it and returned. So we need to make sure that's 0 every time we start it up. And then we're going to cast that to a string so that we can display it to our GUI later on, as well as our gems total. And the reason why we're grabbing this from the game manager is because if we had multiple people working on this, or I just didn't want to go through and hard code everything, the gems have their own script, which add, let's pop over there really quick, they add themselves to the total when they are created so that you don't have to go through and edit those numbers, and they're always accurate, which I thought was pretty important, and I'm looking for that now. We also add them to a list so that we can re-enable them properly, because if they are, for example, disabled, I have them on enable and disable. I don't want to destroy any objects. Everything that exists should simply continue to exist, and then just get set active or set active to false. That said, when I re-enabled the game screen and the level objects, both of which are parent objects to these things, so they're pretty deep in a child class, or child object, not a class, tree, they did not get re-enabled for whatever reason. So I had to make sure that would happen, and to do that, I did a gems list, which I stored in the game manager. And then whenever we enable our gameplay screen, in other words, to play the level again, we are going to activate each of them. So there's a for each here. For each gem within this list, we're going to set active to true. And that was how I worked around that little sticky situation with them being stuck in that tree and not getting enabled. That said, I'm looking for the line. Here it is. So on start, they add themselves to the total, so that you know how many are in the world at a time. And then gameplay. Where did you go? There you are. We set our heads-up display on enable, just to make sure that that's completely accurate. And then we do the same thing with our lives. We're going to set them, and then we will update the GUI as well. I'm looking for that. I may have that in a different location. Anyway, yeah, here it is. Set live HUD on update. And then when the player reaches 0, so within our gameplay script, whenever the player should have no time remaining, we're going to check and make sure that they didn't just grab that last gem within the exact same moment that they ran out of time, because if so, we will... Oh, wait. I'm sorry. That's coming over here. Check and make sure that they didn't grab it within that amount of time. And if they did not, then they weren't quick enough and it's game over. But if they did win at the very last moment, then we will throw them that victory screen. Otherwise, if time reaches 0 and they didn't have all the gems, then it is game over. If the player collects all of the gems before the time runs out, so this has nothing to do with time, just they've collected all of the gems, then we're going to go ahead and load the victory screen. And because this works with our finite state machine, with our game manager, it's going to disable the screen that we're on, enable the victory screen, and send us into that nice, clean management system, which is pretty awesome to work with. If the player loses all of their lives, or in other words, if they've been caught too many times, then it is game over. So once again, we're just setting that game state within the finite state machine in the game manager. And this was just for testing purposes, so that I could quickly win by pressing the spacebar. So you can go ahead and ignore that. And then this was just our set lives function, which was to store our number of lives that we currently have to string, and then to display that string onto our text mesh protext through the setText function that comes on the object. So that's the gameplay script. We went over the gem script, how they add themselves both to the total and to the list. And then also, here's the other thing. When you collide, or when you enter their trigger, because it's not a collision box, it's a trigger box, should you be the player and not the cat, then the gem sound will play. We're going to add 1 to our gems collected score. We add we take that to a string, and then we also we grab this once more. our gems to total. We display the number that we've collected versus the total that there are within the level, and then we set that object, which is the gem, to false. So that's how all of that works. And then also a benefit of having those screens, the audio component here, this gem sound, is on the screen, not on the gem. So that prevents it from being cut off too quickly by this object being set to inactive. It can still get interrupted by another gem being played, so if you collect them very quickly, then that sound will be interrupted, but that's okay. As I'd said before, it's just free sounds, and there's a little bit of a delay, but still pretty good, I should say. Let's see. We have covered everything there is in here. Line of sight, field of view. We definitely covered everything in here. The last thing to do is to play the game and show you the quit application buttons. So, did I show you how all of these things... I showed you the title screen. I'd like to show you once more with the gameplay screen how these UI elements respond to different aspect ratios, just to show that they are always pinned to the top, and they're in their proper locations. So, oops, my goodness, that's the scene view. Okay, let's go ahead and play our game then. And we will pick, doesn't really matter, this one. Get a volume up there. Okay, so we have our start screen. We have our gameplay. We have our cat, who will chase us when she sees us, and will become confused and return to patrol when we escape. Oops, she caught me. I'm gonna die. My time's running out. Okay. Now when I try again, brings me back to the start screen. I have no gems yet. I've got a full timer and a fresh game board. I'll go ahead. Oops, I missed that one. I might die again. Let's see. And there we are. Victory. And then here's our application.quit. That quits the application. So that is SneakyMcSneakFace, or Spyro, A Life of Crime. And that is my project. Thank you very much for watching.